right, 9.2, graphing quadratic functions. This is going to be an intercept form. So it's a different form. We have several different forms we've talked about. We've had vertex form, y equals a x minus h squared plus k. So we've looked at that and said, all right, we have that equation. Where's the vertex? We can look at it. We can find the vertex. It's always the opposite. So the vertex is at 3 and then -4. And that would be the vertex. That's one of the forms. Then we just finished up where we have y equals a x squared plus bx plus c, and we have something like this. Y equals x squared plus 2x plus 1. And then we use this formula that we got done yesterday. X equals minus b. So b would be 2 over 2 times a, and a would be 1. -2 over 2 would be -1. Then we put the -1 back in the equation to figure out y. And if I put in -1 squared plus 2 times -1 plus 1, all that's going to end up getting me 0. And we find the vertex at -1, 0. Those took a little more work. Okay? So those are two different forms. The first one's called vertex form. The second one's called standard form. But now we have one called intercept form. So in the intercept form, it's going to look like this. You still have an a value. And what's true about a, right here, if a is bigger than 0, it opens up. If it's positive, it still opens up. If it's negative, it still opens down. That's true on all three forms, when the a is positive or negative. But this one, we're going to have something like this, where we go y equals 2 x minus 4 x minus 6. Now, it's still true about the opposite things, but this isn't automatically the vertex. These are where this thing crosses. So this one, we would find that x is 4. And that would be our value here for p. It's the opposite. So if we were graphing it, we would go to 1, 2, 3, 4, and that's one of the intercepts. It's where it crosses x. When something intercepts, that means it crosses it or connects. All right? The other intercept would be 6. So 1, 2, this one's at 6. If we want to find the vertex this time, the vertex is halfway in between, or the axis of symmetry. So the axis of symmetry, if we take 4 plus 6, putting it in this formula, 4 plus 6 is 10, divided by 2, it's at 5. And then we're going to put 5 into this equation to figure it out. So that's what we're going to look at. But we'll find the vertex in between those 2 points. All right, so we're going to jump in. We're going to look at this. And we have a quadratic function. This one has a negative in front, so it's going to open down. That's the same as always. But first, we want to plot the intercept. So the first intercept, it's always the opposite. So the first intercept is at -1. So we're going to go over here. We're going to put a point on x is -1. And it's right on the x line. That's why it's called an x-intercept, okay? And then the other intercept is at 5. So we're going to go over here and we're going to plot the other intercept right on 5. Now the axis of symmetry, you simply average those two. So you take -1 plus 5 and divide by 2. Well, 5 minus 1 is 4, and 4 divided by 2 is 2. So that's our axis of symmetry. So what's cool about it, between those two, you always find the middle. The middle is at 2, right in between those. If you look from each of them, that would be 3 away from this one and 3 away from that one in terms of its distance. But now we want the vertex. So the vertex is the same thing. You have to use the equation. So you're going to want to take your calculator and you're going to want to put in for x the value of 2, just like we did with the last one. So we're going to start typing in. We're going to put in a negative. Make sure we have a calculator if you need one. And it says on here x plus 1. So instead of x, I'm going to put in a 2. So actually, I'm going to do it this way. I'm going to go a little slower while everybody grabs their calculator. It's x plus 1, and it's x minus 5. Now, if I were to hit enter, it's probably not going to get me anything because it says the variable's not defined. You can't type the variable in, okay? So I'm going to go up. I'm going to copy that. I don't want to put in x. I want to put in what we found x to be. When we found the axis of symmetry, which is halfway between the two intercepts, when we found it, we're going to replace the x with a 2. So in both of those places, I'm going to put in a 2. And then it does it for me. It says it's at 9. So when I put in 2, what comes out of the equation is 9. How did everybody do? Did you get the 9? So now we're going to graph that. 2, 9, that's our vertex, and we get the idea of our parabola. Our parabola is pretty tall, goes up to the 2, 9. I should have hit the point a little bit better. There we go. And then it says draw a parabola through the vertex, and we did. Now, is that a maximum or a minimum point? That's a max. The x-intercepts are -1 and 5. The axis is at x equals 2. Our vertex is at 2, 9. Domain, as always, is all reals. And the range, since it opens down, is less than or equal to our y value of 9. Now, we just got to get used to a new form, but we see a lot of the things are the same. It opens down because it's negative. We find the axis, we put the number in, we get the vertex. You see how it's really similar to the last one? It's just another form. Okay, so this one. Let's find the x-intercepts. Remember, they're always opposite. So the x-intercept is 2 and 3. Now the axis, sometimes we have to do a little work. 2 plus 3 divided by 2. Now you may want to use a decimal, but that would be 5 divided by 2. And on your calculator, making it a decimal, it should be at 2.5. So the axis of symmetry is x equals 2.5. And that's okay. We can have a decimal. I'm going to put on the two intercepts, 2 and 3. And in between those, if I drew a line, and it's kind of hard to land in between those, I'd have 2.5. Okay, I'll give it my best shot. My board bends a little bit there. That's supposed to be in between those two. So my vertex is at 2.5, comma, something. So we have to take 2.5, we have to put it into the equation. So again, the idea, and I wouldn't write it, but it's x minus 2 and parenthesis x minus 3, right? Instead of x, we're going to put in 2.5. Calculator will do the multiplying for us, and we get negative 0.25. So our other value in here, negative 0.25. Our domain is all reals. Our range is y is greater than or equal to okay, negative 0.25. Is it a max or a min? It's a min because it's a low point. Good job. Any questions on this one? Starting to make some sense? right, part C. Now this one's a little different. It actually has two things. It's got x plus 4 and x plus 4. The issue is, in terms of our intercept, the opposite is -4, and there's only one -4. Now what that means, it only hits the x-axis once, but that means that will be the vertex. Because the vertex, since it is two -4s, -4 plus -4 divided by 2 is -8 divided by 2. It is -4. What it means is the vertex is going to be right on the line. So this, when we graph it, that is our turning point. And since we already know that's it, if I were to put -4 in here plus 4 and square it, you can do it in your calculator, but -4 plus 4 is 0. And 0 squared is 0. So our axis of symmetry is -4. Our vertex is -4 comma 0. Now, the same rules apply as the other parabolas. Out here, if we look, the A value would be 1. So this one, it's opening positive. So if A is 1, we can simply go 1 to the right and up 1, 1 to the left and up 1, and we can get our graph. We really don't have to do much more thinking than that because we already understand how A works. If A was 2, we'd go up 2 and over 1, up 2 and left 1. So we know it's a minimum. We know the domain's all reals. It's y is greater than or equal to 0. Oh yeah, B-E, B-E. Okay, just see. Okay, so now this one tends to throw students off. As soon as they see just the x, they don't quite get this value is A, this x, and this x plus 6. You may want to look at it this way, but what's happening to this x here is we could say it's subtracting 0 or it's adding 0. This is C? This was A? Oh, so this was the example? Okay, so we're, in terms of your examples, this one's A, this one's B, and we're now on C? That's fine. All right. Okay, but do you get that when you see this x, you don't have to write it like I did, but then you understand that 0, it's really about what number I put in there. If I put in 0, that'll be 0. If I put in -6, that'll be 0, because -6 plus 6 is 0. Okay, so this one's going to open down. I already know because it's a negative. So if it's going to open down, will it be a max or a min? It's a max. Now, I haven't graphed it yet, but if you know that it opens down, you know it's going to be a maximum. If you know it opens up, so you can always, look at that stuff and you can predict it. So if it opens down, it's going to be y is less than or equal to something. The domain is all reals. Whoops, that's supposed to be for the range. Now the vertex, you take the two numbers, you take 0 and -6 and you average them, you're going to get -3. That's the axis of symmetry. It's also part of the vertex. To get the rest of the vertex, you have to put it in. Now remember, that 0 is not technically there. It's okay if you put it there. But we're just going to put it into this equation. So we're going to take -2 parenthesis x times x plus 6. But instead of x, we're putting in -3. Now notice I put in parentheses both times. And it's good to do that because that's -2 times x times -3, and it was +6, right? Yep. So I get 18. Whoa, that one shot way up there. So y is less than or equal to 18. Now this one, it only goes up to 10. So if we were graphing this one, we'd put a 1 at 0, 1 at -6, and then -3 goes up to 18, which is way up here. So 18's off the page a little bit. That's supposed to be, sorry, we got a little sloppy writing with the mouse. We'll fix it. Y is less than or equal to 18. That's an 18. Right there and there. Those are the same. All right, are we good? Next one. So D on yours. Okay, graph the quadratic, fill in the missing information. So this one, is it in the same form we've been doing today? No. So this one is actually back in the other form. So if it's in the other form, we're going to adjust. So this will be practice. This is what we looked at yesterday. The other form had an equation, x equals -b over 2a, to figure out the axis. So b is taken out, a is taken out, and we got to put it in. B over there is a -24, and a is 3. So we get +24 because a negative times a negative is a positive over 6, and that gets us 4. So our axis of symmetry is x equals 4. Our vertex is 4 comma something. So somewhere on here is the fold line. We have to then take that 4 and substitute it back in. It's a throwback question. Three x squared minus 24x plus 36, but of course we're not doing x, we're putting in 4. Notice whenever I wrote the x, I already put it in parentheses. That's a good habit to get into. So letting you type 3 times 4 squared minus 24 times 4 plus 36 is -12. So 4 -12 is a little bit off the thing here. Now our a value was 3. So from that dot, I'm going to go up 3, 1 to the left and 1 to the right. And it gets me kind of a stretched out parabola, stretching upward. So we have definitely a minimum point. And we're trying to find the x-intercept. On this one now, we're going to find the x-intercept. So we're going to also throw this one back. It's a good review question. To find the x-intercept, I want to try to put it in the other form now. So I'm going to take this, and I'm going to do what we call factor. We already know how to factor. We're going to take the 3 out of everything, and we would get x squared, because 3 times x squared is 3x squared. Minus 8x. Why? 3 times minus 8 is -24. 3 times 12 is 36. Everybody understand that? Now remember all that time we spent factoring. X and x. Look familiar? How do we get 12? 12 is 1 times 12, 2 times 6, 3 times 4. Those are all the ways to get 12. Multiples to get 12. Which ones will add to 8? 2 and 6. Since it's negative 8, I want negative 2 and negative 6, because a negative times a negative is a positive 12. But now that just gave us our intercepts. Our intercepts should be at 2 and 6. So if we continue drawing these things, our intercepts are 2 and 6, but we had to factor to get there. Now let's see if that works. 2 plus 6 divided by 2 is 4. That was our axis of symmetry. It works the same as the other formula. Our range, y is greater than or equal to negative 12. So sometimes to find those intercepts, you may have to factor